I just want to mention that the structure of the panels is such that the speakers will speak first, all the speakers, and then when everyone's finished, then we'll have questions and answers. So I want to thank Nancy for a very informative and beautiful talk. Thank you. And now I'd like to welcome our second speaker, Masahito Kawamori, who's a professor at the Media and Governance School at Keio University in Japan. Before joining the university, he'd been a senior research engineer of NTT to do research and development in the application of artificial intelligence to convergence systems for mobile and fixed telecommunication, such as conversational robots and humanoids. And in 1998, this became a part of Japan Science and Technology Agency's program called Core Research for Evolutional Science and Technology program that was aimed at creating the brain. Since 2000, he's been involved in projects in and outside of Japan to apply metadata and ontology for various services, including but not limited to telecommunication and broadcasting, which have led to global standards that are now concurrently commercially deployed in a number of services. He's actively involved with the International Telecommunication Union that's part of the United Nations. His talk is entitled Making Intangible Cultural Heritage Tangible, and I'd like to welcome Professor Masahito Kawamori.
I'm sorry. Thank you very much for a very kind, nice introduction. And it's my great honor to be here, and it's a great pleasure. And thank you very much, Andrea and Xian, for inviting me. Okay, so this is the beginning of the slide. And so my talk is titled Making Intangible Cultural Heritage Tangible. And my background doesn't include cultural heritage per se, but in the bio, I'm interested in applying some of the things that I've been doing into cultural heritage science. Before going to talk about my talk, just briefly introduce Keio University. Keio University is the oldest institute of higher education in Japan. It was created in 1858, and it currently ranks third in the world for the number of alumni holding CEO positions in Fortune Global 500 companies. So it's famous for being rich alumni. It also ranks 9th in the world in the Times Higher Education's alma mater index. The university is one of the Japanese Ministry of Education, Culture, Sports, Science, and Technology's 13 Global 30 projects. So it's supposed to have many foreign students and also conduct classes in English. So if you're interested in coming over to Tokyo, please select Keio University as one of your targets. And this is from Wikipedia anyway, so I don't know how reliable it is, but this is the information summary. But anyway, so this is I think the text itself, actually Nancy just presented to, so I don't read it, but this is a UNESCO Charter of the Safeguarding of Intangible Cultural Heritage. And it says intangible cultural heritage is practices, representations, expressions, knowledge, and skills, as well as the instruments, objects, artifacts, and cultural spaces. So intangible cultural heritage actually sort of include tangible artifacts and objects. So when I thought of intangible cultural heritage, how can we transmit? You know, it's kind of what was out of imagination. But if you think of objects and artifacts that are associated with intangible cultural heritage, we can do a lot of things. And also, it came to me, it's extremely difficult sometimes to record and transmit intangible knowledge and expressions and representations, because it not only it takes, for example, knowledge representations or recordings of, for example, songs and stories, but it also includes the environment that surrounds this intangible cultural heritage. So, and one of the things we have to think of is this process that allows traditions and shared knowledge to be passed. So it's not just instantaneous event, but it's a sort of a series of events, and it's a process. So again, this is not just a snapshot of intangible knowledge or intangible cultural heritage, but it's a process. So we have to record and transmit this kind of series of events that can be captured as part of as sort of a cultural heritage entity. And so this seems to be a very difficult task. So I thought I would first start thinking of heritage science and also what intangible heritage science would do, or intangible heritage itself is. But anyway, so this is a summary of what Andrea and Xian sent me as part of the, how should I say, prospectus of heritage science. Heritage science is a multidisciplinary field where results from a wide range of studies, including the arts and humanities, to the fundamental sciences, chemistry, physics, mathematics, biology, and finally economics, sociology, media studies, computer sciences, and engineering. One of the obvious benefits of this science will be that it enables us to interpret, conserve, access, and manage cultural heritage. And for that purpose, we need clear action plans and solutions in response to and in anticipation of the challenges arising from cultural heritage issues in society. So I think this is a sort of a statement of what we need to do and the background. So the problems are how to make these intangible arts tangible and how to record them and make them shareable. So I will concentrate on these tasks. So in this presentation, I will consider two approaches to the conservation, access, and transmission and management of intangible cultural heritage, both of which are necessary for heritage science. The first approach is the holistic approach, which takes advantage of the recent development in digital multimedia technology. The second is the analytical approach, which is rooted in the interpretive semantic analysis in artificial intelligence and cognitive science based on metadata and ontology. We review briefly the basic concept of metadata and ontology as well as for their creation. So before going into some approaches, the two approaches that I just mentioned, I would like to take some examples of intangible cultural heritage, because I think it's good to clarify the tasks that we have in front of us. So I'd like to take three examples. I think they are intangible cultural heritage. One is culinary art, which is cooking in a sense, and tea ceremony, and calligraphy, brush painting. So I first thought of culinary art, which cooking as an intangible, very typical intangible cultural heritage. And Singapore is very famous for rich selection of food and dishes. So I thought that it's a time-apt selection. So I thought of cooking as And then I found out that cooking is extremely complex. It's an extremely complex form of cultural heritage. First, I thought cooking can be thought of as a collection of recipes. So recipes are somewhat like computer programs because recipes are instructions to cook. So instructions to do certain tasks. So in a sense, if you collect recipes, you can sort of make an inventory of foods and cooking. But the actual cooking is an extremely complex creative process, not describable in a recipe, I just found out. Because as I said, in an intangible cultural heritage, you have to take into account of not just the act itself, but the surroundings and the relationships between these objects and agents. So it's not just cooking recipe that will be good enough for describing culinary art. First of all, you have a great number of tools and utensils, like knives and forks, pots and things like that. These many devices, many tools. You have to know how to use them, how to prepare them, how to design them, all of these things. And also, of course, there are ingredients, many different kinds of ingredients, including spices and sauces and all kinds. So if you just restrict yourself to the Western type of culinary art, you have an awful lot of inventory of ingredients. And then you have to prepare the ingredients by cutting or shaving or whatever, or squeezing. And then finally you combine with frying or boiling, things like that. So they are all so complex process. So it's not just a recipe, culinary art. But these processes still do not cover everything that cooking involves because it leaves out, for example, the most important element in cooking, which is taste. So even if you can create, according to a very precise recipe in a precise manner in a physical action, but still you don't know how it tastes. And then cooking is not just taste. Additional attributes such as taste, smell, color, temperature, stiffness, and so on are all extremely important, but are still not readily describable in a current physical manner, for example. So culinary art seems to be a daunting task to be described and recorded and transmitted at this stage to me. So I just thought of something a little bit less complicated. So I thought of tea ceremony. It's the Japanese style. So this is a Japanese traditional tea ceremony, which involves actually not just drinking tea. Drinking tea itself is pretty simple, but all the surroundings like the room, utensils, pot and cup, and the movements about pouring water, making tea, and so on. It's pretty complex, but it's not as complex as culinary art itself. So I thought about what would be, so the utensils and tools that tea ceremony uses. So these are things that you have to prepare to have in order to have a traditional tea ceremony. And then very delicate way of boiling water, pouring water. They're all described in rules. And then use a special kind of what they call matcha green tea. It's very kind of bitter tea. And this is different from ordinary green teas that we drink usually, and it's not consumed in other situations, just for this. And again, this is ritualized and very specialized way of serving this. And then, again, using the water, hot water into the pot, the cup, very special. And there's a strict rule on how the ladle is to be used and held and carried and put, placed, and things like that. So you have to know all those things. And then stirring the tea, and then finally you make the tea. But this cannot be offered. It's not something that you drink, but you offer to the guest. And then this is, again, a very ritualized, special way. And then, as you can see in this photograph, there are other guests and the person who made the tea, and also there's a writing on the wall, and also the cup. So in a typical tea ceremony, you're supposed to sort of comment on the artifacts in the room. And so you have to communicate. So you don't drink just like that. You communicate. So tea ceremony is a sort of a communication process. So it's not just drinking, and it takes long process. So this is one cartoon that explains how to do the tea ceremony. As you can see, this is the guest. So you guest goes into the room and then get the tea, and then cleans the teacup, and then get the sweet, and bows and talks to the host and things like that. So this is not just drinking, but it's the whole combination of conversation, cultural exchange, and also rituals and things. So it's again, although it is not as complex as cooking, but it's pretty complex. And it's a dialogue. It's a by-agent thing. So it's even more complex in a sense. There's involved many agents meaning the guests and the server, and the environments about the room, tea, flowers, and things like that, and then the interaction among them. So now I started thinking of brush painting. So this might be a very simple example because there are not many tools to be used, just brush and the stone and the ink and paper. So the tools are smaller in number. And then there are some strict rules how to draw or write with the brush painting. And so this is also like instructions. So you can sort of program. And it also involves some bodily movements. This is a very extreme case of brush painting that they're high school students in Japan, and they are in a club, extracurricular club, and then I don't know what they're doing, but probably the New Year's ceremony or something to write very big paper, a certain character, Chinese character. So after looking at these different types of intangible cultural heritage, I came to realize that it is extremely difficult to describe these things. And even a very simple task such as brush painting takes up a lot of resources to record. And but I think it's still doable to a certain extent. So I will explain these two approaches that I just mentioned. One is the holistic approach. So before analyzing, we have to record as much as possible, as accurate as possible. So the holistic approach is to preserve, holistic approach to preservation of cultural heritage will use especially multimedia tools to capture the process as a whole as accurately as possible. So the keynote speech by Harold mentioned capturing, things like that. That's exactly what this holistic approach takes. And most ready way is to use video cameras and microphones to record events, such as someone doing calligraphy or interviews to collect stories, descriptions. Again, this is, I think it's a commonly used technique. And for physical motions, motion capturing is also applicable. So this is sort of a holistic approach. And currently, multimedia for cultural heritage, again, taking examples from Harold's presentation, we have an awful lot of inventory of technologies to be used. With the advent of modern technology, the documentation and preservation of cultural heritage can be done not only with text, but also multimedia, enabling more true to the fact, first-hand recording of cultural heritage, and especially with super high definitions like 2K video and ultra high definition like 4K and 8K devices. And these cameras and devices and displays and TV sets are already available in the market for reasonable prices. So it is needless to say that better resolution video will enable more accurate preservation of visual cultural heritage and will provide better appreciation of the audience. So these are cameras. So GoPro, that was the one that Harold was also mentioning. So this can be used on a helmet, either to capture, record the surrounding as well as self-video. And this is a camera from Sony 4K. So 4K recording, video recording is nothing special anymore. I think it can be done, although it is not possible over broadcasting to deliver, but still we can record. So it's better to record things in 4K. And this is an 85-inch 8K TV from Sharp. And there are certain companies like Sony and I think Sony and Sharp especially, they have produced 8K. So 8K TV sets produce 120 frames per second. The current 2K is 30 frames per second. So it's 4 times better resolution, not just better resolution, but also better frame rates. So it's more accurate and it's closer to reality. So these are all available already, and we can use them. Another thing is motion tracking and capturing. So as Harold explained, motion tracking or motion capturing is already widely used in gaming and movies, as well as medicine and sports and many different disciplines. It is a good way to record, preserve, and share information about culture heritage that involves physical actions. And we can actually combine this with 3D or augmented reality. So motion tracking using 3D AR to obtain controlled motions, because you have some controlled stimulus, and then giving simulated environment, visual environment to the subject so that he can react to a certain stimulus. And 3D game that involves the whole bodily action is already available in the market. So I was in Las Vegas last week, and I took this video, so I will show it to you. So this person on the right is walking on this tread, and he's actually wearing this 3D display on his eyes. And what he's seeing is on the left. So he's tracing some enemy, and he's shooting with his gun. Yeah, sound is not synchronized. See, so even if he's just he's actually he's just staying in one place, but it seems like he's running now. He's walking, running, he's watching, he's trying to shoot. Actually, this can be used for I thought this would be a good exercise tread because you won't get bored. But anyway, so by using this kind of 3D interaction with motion tracking, motion capturing, you can create sort of an interactive motion capture images and data. And that way you can sort of control how that subject moves. So it's an interesting way. Another interesting motion capture application is at Keio University, actually a motion copy system was developed in 2012 to track calligraphy strokes, exactly as I mentioned, I just said. So it first records the strokes of a human being who's called the master, and then reproduces the strokes accurately as much as possible. It has a motor that moves as the person moves the brush, and then the moves are recorded digitally. Then the robot uses the same motor to produce the exact same moves. It's a combination of motion capturing and robot. So by combining these two, you can create sort of a realistic representation of writing. So this is the actual robot. So this is the master. So he draws, and then the robot records all the data digitally, and then repeats the same motions. Okay. Anyway, so and this is the data on the left-hand side is the description of the data, and the waveform shows the actual data, digitized information. So in a sense, it records not only the actual data, but also the analysis of the data. And so this system can be seen as a bridge between the holistic approach, which captures everything, and also the analytic approach, because it gives some information about certain interpretation of the data. And this is the result, the comparison between the original and the copy. It seems quite close, but if you see on the right-hand side, top right-hand side, there are some differences. And the differences between these show that it is not enough just to track the human action, but it's also necessary to take the external environment and tools, the movement of the tip of the brush and spots made by the ink and so on. It's not just the human action, but the tools and also the environments and the atmosphere will have an impact on the results. So that means you cannot just blindly copy the master. The robot has to take into account and to have a feedback loop so that he can correct his positions according to the environment. That's probably why the second, copy is not as good as the other one. But it's pretty close. So these are the approaches that can be done with the holistic approach to record as much as possible and as accurately as possible. And then the analytical approach is to record, but not just the whole thing, but in an analytic way. And in this aspect, I would like to talk about metadata and ontology for cultural heritage science. Use of metadata is used to clarify the cultural environment of heritage, and use of ontology to clarify the relationships between these cultural heritage entities. And there's area in artificial intelligence called natural semantics or naive semantics, which is a little bit different from semantics in a sense of physical attributes. So this is more qualitative analysis rather than quantitative analysis of intangible and cultural heritage. And but it also uses a mathematical method or a formal method. For example, first-order logic or knowledge representation, somewhat like a formalized recipe for cooking. And digitized data such as track monitoring data and MIDI files, for example, can be used as part of metadata, in a sense. MIDI is exchange format for music. So rather than having a printed score, you can have MIDI as a digitized information of that information, of the music. And dynamic Bayesian networks to semi-automatically tagging the actions using the metadata and ontology. I'll talk a little bit about dynamic Bayesian network. So metadata, what is metadata? Just to give you a basic idea of what it is. It's not the data itself, but it's data about data. It's structured and encoded meaning machine readable, and it describes characteristics of entities to aid in identification, discovery, assessment, management. So this is a typical use of metadata. So examples of metadata: library card, electronic library card, electronic program guide, which gives you which programs you want to watch. iTunes Music Store's catalog list is an example of metadata. Electronic health record, which is a description of your health, and also it sometimes gives you your insurance account and insurance company's name so that the doctor can contact them when you're in trouble. So this is an electronic health record. It's metadata. Search engine search result. For example, Google is one of the biggest metadata companies in the world because they control metadata of search results and what you watched, what you searched for. And attributes of multimedia data. This is most relevant here for cultural heritage. So I'll just give you an example of metadata. It's a movie from IMDb. It's a movie, Titanic. So this is what's displayed on the website. Actually, this is based on a metadata created from the basic information given by the producer of this movie. So it gives title of the Titanic, production year, length, genre, release date, director, writer, stars, synopsis. This is actually the same information from here. I just wrote it down. And what you can do is to make it a sort of a formatted way so that machine can read. Machine meaning computers can read this in a certain way. One way is like Excel format, which is more or less familiar to everybody. And another format is called XML. It's like HTML in a web page, but it's more structured. And actually, this XML format has become a standard format for metadata. And this is one of the important standards is called MPEG-7, which I will be talking pretty soon. And RDF has been adopted by many. Actually, RSS feed uses this RDF format. And XML can easily be translated to or from other formats like Excel sheet or any kind of text format, actually. So this is a sample metadata in XML, which I just wrote it down in here, like this. And this becomes like this. And then this can be easily parsed and easily processed by a machine. And it can be used for searching, cataloging, and also for displaying as well. So this is one clear example of metadata, how to use it. But how do we use it for multimedia case? So this is an example of multimedia metadata. And this is the original. The waveform, oh, I'm sorry, it's muted.
ようこそ
Yeah, so it's in Japanese, meaning welcome. And so this is the actual waveform. And this is Y-O-K-O S-O, yokoso. And these are called phonemes as the basic components of speech. And this can be expressed as an metadata, as like this one. So this, the first segment is Y, duration is 33 milliseconds, and O is 281 milliseconds, and things like that. So this is sort of an association with the waveform, actual waveform, and interpreted sequence of sounds in meta XML format. And there is actually already a standard for this kind of multimedia metadata, which is called MPEG-7. It's a multimedia content description standard. Some people may know the words like MPEG-1, MPEG-2, MPEG-4, because they're very readily available on the websites, because it's one of the most famous encoding of videos and audio. But this MPEG-7 is not an encoding format. It's description of data. And the description will be associated with the content itself to allow fast and efficient searching. So when things are in digital format, you cannot search, you cannot watch, you cannot see. Everything is binary. So you have to have metadata to search, and search in a very intelligent way, an efficient way. And it uses XML. MPEG-7 uses XML. And this is one use of MPEG-7 for object temporal segments. So what it can do is to describe segments of a video, for example. So in a temporal description, you can have chapter information, and also you can have object information, spatial temporal decomposition. So you have objects taken out, extracted from the original video. So this is already standardized and can be used. And another example is, okay, so this is the metadata in XML format, which has a photograph of 3 persons. And first one is ID SR1 and SR2 and SR3. And we have metadata tagged that says Roosevelt. I think this is wrong, though. SR1 is Churchill, I think. Well, anyway, so so this shows how important metadata is, you know. Yeah. Churchill becomes Roosevelt. But anyway, I don't know. Maybe probably this person is not either from the UK or the United States. So, anyway, so this is how metadata can be used. You have the video, and you tag with XML, and then you search. And it can be done with text as well as data itself. So for data, we have this kind of description. In that case, the numbers all show the actual data. So by doing this, what you can do is it's independent of the application. It's just the data itself. You can create your own application to see this metadata. And actually it describes what kind of application it was used, what sort of format it's using, blah, 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 frequencies and things like that for videos as well as audio. So it's a good way to store information as metadata, and you can include your data itself there so that you don't have to have a specific application, but it's a standardized application. You can create your own application to watch this. And then so these are the metadata that I've been talking about. Now, ontologies. So what does ontology do? Ontology is a body of formally represented knowledge, and it's based on a conceptualization, the objects, concepts, and other entities that are presumed to exist in some area of interest in the relationships that hold them. So in the cultural heritage context, for example, brushing, brush painting, or flower arrangement, or any kind of cultural heritage, this is the domain, and you you describe the relationships between the tools and agents and the process. So it's sort of an explicit specification of a conceptualization. It's a description of the ideas, not just objects. So this is an example of a very simple ontology based on a network. So bird is an animal, and plumage, feathered. So bird has a feather, and canary is a bird, and Tweety is an instance of a canary. So that means Tweety must have a feather. So this is a very simple representation of the knowledge about birds. Of course, actual life is not so simple. So for example, Tweety is a penguin, then he's not feathered. So how shall we account for that? So that's a big problem still. But anyway, and it can become very complex like this, and it has many different attributes, properties, and things like that. But still, we can represent in a certain formal way. And actually, ontology can be taken as a sort of a database. So you create a database based on, for example, Excel sheet. Then you can translate that into a form of ontology so that you can create your ontology based on database as well as metadata. Oh, this is great. And the hardest part of metadata and ontology is creation because it costs so much resources. So use of automatic as well as manual generation is important. Pragmatic approach as well as theoretical approach has to be taken and target long-term interoperability and usability. Long-term interoperability is very important, as Harold's this morning's presentation said. Digital applications and digital data has very short lifespan. It can be used for just 2 or 3 years, and then all of a sudden the operation system changes and you have to change the application, update. And it happens not concurrently, so you have to do it, watch your applications all the time, or sometimes your license expires and you have to buy another one or things like that. So how to create metadata and ontology? As a large amount of raw data can be expected, one can put mature technologies as rhetorical structure theory and the theories in text summarization, document analysis, artificial intelligence, into practice in creating new metadata. So, and the recent development in Dynamic Bayesian Network is promising for connecting raw data with metadata. So I will talk about rhetorical structure theory. Rhetorical structure theory is originally created for computer-based text generation. And later it was found to be useful for text summarization and other applications. So generation as well as interpretation. It addresses text organization by means of relations that hold between parts of text. It explains coherence by postulating a hierarchical connected structure of text. So it's one way to describe stories. For example, you record a story of lost tribe or something, and then you can analyze the story in terms of this rhetorical structure, and you give a formal structure. Another interesting theory is called naive semantics, which I just touched on. And it's an approach used in computer science, again, for representing basic knowledge about a specific domain, like cultural heritage, and has been used in applications such as the representation of the meaning of natural language sentences in artificial intelligence applications. So I just take one example of naive semantics. The sun rises in the east, which makes quite meaningful. But physically speaking, this doesn't mean anything, or imprecise or incorrect. Because the sun doesn't move, but the earth does. So the sun doesn't come in anywhere. The earth is moving around. So, and east itself is a relative term with north, south, and west. So you can say that sun is there and earth is relative to sun in such and such altitude and blah, blah, blah. But that's the actual physics and actual semantics. But in terms of natural language, the sun rises in the east is exactly what it means, and it makes sense. And so we have to describe, we have to have a way to describe this kind of semantics or meaning, and otherwise we wouldn't be able to describe any knowledge of cultural heritage, because most of them, especially like people in the rural areas, don't know anything about either sun moving or earth moving. They don't care. They probably care about fish coming, or the rain will come tomorrow or something like that. So, but we need this kind of naive semantics. So now I'd like to go to Dynamic Bayesian Network, and this is interesting development. Okay, so just as I explained, speech can be seen as a sequence of phones, and you have words, and then words make a sequence of, sentence is a sequence of words, and text is a sequence of sentences. So if you can take care of these sequences and represent them, then you can classify, segment, and predict such sequences. And that's what Dynamic Bayesian Network is supposed to do. It models sequences of events as a network of events with stochastic connections, transitions. It's a generalization of the well-known hidden Markov model, which was widely used in speech recognition. Just don't worry about what hidden Markov model is. But anyway, so it's being used in the speech recognition, but nowadays DBN, Dynamic Bayesian Network, is most widely used. And it can handle multimodality. So what does that mean? If you are understanding, you try to understand a person speaking in front of you, you're not just listening to his speech, but you're also watching his lips. And also you expect some kind of articulatory physical movement of the mouth and tongue, which might not be visible clearly, but you expect because you know how to use your tongue and mouth yourself. So in a sense, when you hear, you repeat the same articulatory movements in your body, in your mouth. So our speech understanding is not just listening to the physical waves, but also watching the visual images as well as replicating the movements in the mouth. So that's why if you see someone talking and dubbed with different sounds, like when someone is saying ma, and you see someone say ka, and the video is dubbed with the sound, you feel very, very strange, because you expect, when you expect the sound ma to come into your ear, but actually you hear ka, which is totally different because you don't puff the mouth or lips. So it's very important to have this capability to treat multimodality, which are three different aspects of sequences. And this is a very good property of Dynamic Bayesian Network, because that means you can, for example, treat dancing at the same time as singing, things like that. So, and also you can tag, like create a metadata. So, so this is just an example of very simple Bayesian network. As I said, these are sequences, and the season, if it's summertime, it's either it rains or sprinkler, and if it rains or a sprinkler is on, the ground is wet, and if the ground is wet, it is slippery. So these are all stochastic information. So if you see a wet, slippery road, then you can infer back that the road is wet. And if the road is wet, you can, at a certain, with some probability, that sprinkler might have been on, or it have rained. It might have rained, or things like that. So it works in both ways, actually. So Bayesian network works causal relationships and searches for explanation of the event with probability. And that's how you use that for speech recognition, as well as all kinds of recognition. Actually, this Bayesian network is all used in many different domains, including medical analysis, as well as financial market analysis and things like that. And so it's simply a graph, x, y, and x1, x2 connected with an arrow. So it can be formatted in XML. Now it has a good synergy with other metadata standards like MPEG-7. Okay, so this is the last slide. And now, before closing, I think one important thing is the need for interoperability. So cultural heritage is so diverse, and it takes much resource, human resource and financial resource, to preserve and transmit it. So many institutions doing different things at the same time, then that's very, very wasteful. So in order for the preservation of cultural heritage in a scientific way to be practical, it is necessary to have some interoperability among the data and metadata. Otherwise, the data collected may be unusable in a few years, just as Harold mentioned, because some proprietary, some company just decides discontinue, something like that. So standardization, sometimes based on de facto standards for such interoperability, should be in the action plan, and cooperation among institutions are also very important. Okay, thank you. Thank you very much. Enjoy your lunch. Oof.